Cap. What is reliability and validity? Reliability is knowing that your results are going to be the same results you're going to get if you gave it to the same student in 2 weeks' time. So it's dependable and it's consistent across time and across items. The validity of your instrument is the degree to which the instrument measures what it's supposed to measure. And the instrument should have this property, should have both properties. They can't have just one in order to be useful. They have to have both properties. Now you might have an instrument that's highly reliable but not very valid, or really test the construct but has no reliability across time. Now we have different types of correlation. We have positive, negative, and none. And in a minute I'm going to show you a scattergram where you can see positive and no correlation. I didn't have room to put a negative correlation, but I think you'll get you'll be able to get the idea of what we're talking about here. Now, positive correlation, the variables move in the same direction pretty much at the same time. You might have a little bit of variance, but you can really see where they're going to be in a band. And they increase simultaneously. So at the same rate, at the same time, pretty much on the same items. A negative correlation you might have high scores on one variable, but those are going to be related or associated with lower scores on another variable that they are directly related to. So you're going to have like a double band, or they will bottom out. You might have a flat line, so you might just have a straight line across the board. That's if you have a straight bright line right across the board. That's not a positive correlation. They need to be moving. You need to have some kind of movement in there. Or you can have no correlation, which they're all over the place. Now, before we get to that, though, I want you to understand the different correlation ranges. The range indicates the degree of relationship between these two variables that are related. Now, you can have administrations of the same test or equivalent forms, as we've talked about before, or you can use the split half, but this is really where you're going to find it. The split half is you've used one of these two administration types. Now, your correlation coefficient range is going to be from positive 1.0 to negative 1.0. It's a very, very narrow range. And it's a good thing, because otherwise it could get really hairy and confusing, even more confusing than it already is. So again, your perfect positive correlation is a perfect 1. Perfect negative is a negative 1. And generally speaking, the way I look at negative correlation, it isn't really negative. I don't want you to think of it as something that's bad. It is giving you information. It's just an inverse informational correlation item. So it could be that the item itself had a reverse scored item that they forgot to reverse score. That could be a really big problem. So you need to always go back and look at those items, make sure that nothing should have been reverse scored that was not designated as being reverse scored. And then of course you have your no correlation, which is going to center around 0. It's going to have very low correlations like 0.1, 0.15. It's going to be clustered right around that 0 point. Now, as numbers get to 0.1, that indicates a stronger relationship. and the inverse for a negative 0.1. Now remember, the greater the degree of relationship, the more reliable the instrument. However, positive or negative does not indicate strength so much as it indicates directionality of the relationship. It's getting higher, you're getting higher scores. Okay, was that what you were looking for in your test? May not be. However, you also need to remember that correlation does not indicate causation. Just because let's think about an example of a basketball team. Just because a player is not tall does not mean that they are not going to be a good basketball player. It really helps, I think, because typically we think of basketball players as being very tall. So does that mean that a short basketball player cannot be good on the court? Not necessarily. And I have a really great example. When I was in my undergrad, I went to University of Memphis. Then it was called Memphis State. And we had a Final Four basketball team. Our basketball team went to the Final Four and won it. Now, to completely throw all correlation statistics away, our major stars on our team, one was 7'1", 7'2", something like that. And then we had our shortest member. He was probably about 5'6", Andre Turner. And he wasn't tall, but he could throw 3-pointers from any place on the court. And that was his strength. He wasn't tall, but he knew how to use what he had to strengthen the team. So just because he wasn't tall does not mean he wasn't a good basketball player. He was excellent in what he did. And so causation or correlation is not necessarily your causation. You need to be very careful about looking at these numbers and saying, oh, well, that's the absolute truth right there. Not necessarily. We're looking at strength of relationship. Now, how do we go about looking at reliability? Generally speaking, on educational tests, we're going to be using a Pearson R. Now, the Pearson stands for the Pearson Product Moment Correlation Coefficient. Sorry, I forgot to write down the coefficient on here. It's used with interval or ratio data, and it is denoted again by a lowercase italicized r. If you see an R in a formula and you already know that you're talking about correlation, you're talking about the Pearson. And what it's looking at is internal consistency. It's the consistency of items on an instrument to measure a skill, a trait, or a domain. Now, let's think about our example of the basketball team. If we had looked at used a Pearson R on the height of all of those basketball players, we would have found that Andre, in his 5'6" status, was a major outlier. And I'm going to show you what an outlier can look like in just a second. He wouldn't match. You'd say, oh, well, that's not going to be a good example. However, you need to go back and look at those consistency of items. You need to look at the skill. You need to look at the traits that are measured and the domains that they are measured in. So you have, and these are the ways that we look at it again: test, retest, equivalent forms, and split half. Now here is the long-awaited and promised scattergram. Now up here in the very top, we have this lovely, lovely positive correlation with an outlier. Okay? You can call this Andre if you want to. Because even though he doesn't match with height, and let's pretend that this is height right here, doesn't match right here, still a very vital member of that team. So we can't just throw it away. You can't. Sometimes people do throw away the outliers so that they can get a better idea of where the points actually hit, but it's probably not a good idea to throw those outliers away. So we have a graphic representation, and we're showing this lovely positive correlation here. Now, so the more closely the dots on the scattergram approximate to a straight line, and we've got this lovely aim line right here, the nearer you are to a perfect correlation. Now look down here. You could draw a straight line here, or here, or here, kinda. Let's see, we could probably get one to go through here. So we've got half a dozen places where we could put a straight line, which indicates that we have no correlation whatsoever.